Okay, on to more optimization questions. So the next question we have this kind of a hemisphere and a cylinder that's forming a solid shape. And they gave us the surface area. And now they're obviously asking for the volume because they have nothing better to do than ask us weird questions. But it's fine, we can do this. So let's take a look at this. Now, usually in an exam, like I said before, this would probably not be a staggered question. They'll just say, hey, find the maximum volume, and you'd be left to fend on your own. But they're doing it structured now because we have to obviously learn what we have to do. So if this was an exam and they're asking for the maximum volume, I would probably start off with my volume formula. And I would write, so I'm not gonna ignore A, B, and C now, but I'm just saying what would I do in a normal exam? I would probably write volume, and then I have to figure out what the volume would be. Now, the volume of a hemisphere, well, a whole sphere should be, I'm just going to write this here, so 4 over 3 pi r cubed. But now this is a hemisphere, so obviously it's going to be half of that. So it's going to be 2 over 3, or 2/3 pi r cubed. Okay, that's a cubed. It's going to take that away. So that's the hemisphere. And then obviously just plus the cylinder, which is pi r squared, which is the base, and then times the height, which is just the height in this case. So I'd probably write this, and then I'd spot that, okay, well, I have two different variables here. I have r's and I have h's. And that's kind of a problem because I want to eventually, because I want to find a maximum, I have to have the same variables on the one side. I only want to input maybe r or only h, and then once I differentiate with respect to r or with respect to h, then I'd be able to find the maximum volume. So that's probably where I would start, and then I'd be like, okay, well, now I need a relationship between the radius and the h, because if I can find a relationship between the radius and the height, and I can write r in terms of h or h in terms of r, then I can sub that in here. Now, because this solid, has a surface area that stays constant of 320, it means that as the radius increases, the h will obviously decrease, and vice versa. So because of this kind of limitation set, this is going to be the case. But now I know they're giving me surface area, and I can write that as a formula. So let's do that. That should definitely be fun. So the surface area they're giving me is 320 pi. So I'm going to start with 320 pi. That's my surface area. And I know that will be equal to the surface area. Let's start at the top. This is going to be a hemisphere. So the sphere usually has a surface area of, just write it here, 4 pi r squared. So this is half that. So we're going to have 2 pi r squared. So 2 pi r squared. That's that part. And the next part, I'll just do the circle at the bottom because that's quick. Pi r squared. And then the cylinder part, as you know right now, the curved part is going to be the circumference of the circle, which is 2 pi r. And then obviously times the height. Okay, because it's actually a rectangle. Cool, so now we have this nice formula over here, and I suddenly see every term has a pi, so I'm going to divide all the pi's away. And I actually have like terms here, so I have 2r squared and plus r squared. So let's rewrite this nice and neat. I'm going to have 3r squared plus 2rh. And now obviously I know in this question they're saying express h in terms of r. But if I was in an exam, I would have a choice here of saying, will I express r in terms of h or h in terms of r? Maybe it'll be less complicated if I had h in terms of r, because there's only one h, and then I'd only have to sub in one kind of big formula. That's the one part. And the other part is, because there's an r squared here, if I wanted to write r in terms of h, I'd have to, I'm not really sure how, well, I'm not saying I'm not sure how I'll do it, but it's going to be a little bit tricky because I'm going to have to factor out an r or something, and there's going to be a square root involved to get r alone. So I'm not really sure if I want to go that route. So I'd probably go the h route because there's only one term with h in here. So all the other terms goes to the other side. So this, subtract 3r cubed on both sides. And basically I'm going to divide by 2r. And I'm left with h. Okay, so that was pretty simple. I could probably rewrite this differently and split those up, having like a 160 over, let me see, r minus 3 over 2r. That's also possible, but I'm just going to leave it like that, and basically I'm going to sub it in my formula here. And yeah, so obviously that's what they're showing me now, like, hey, show that this is going to be happen, but that would anyway be my next step. So we have the r cubed here, and then the pi r squared, and this whole thing is going to be in here, so it's going to be 320. I'm going to make it a little bit easier for myself just by putting this over 2r and minus 3r squared over 2r. I don't have to, but just for the explanation, split them up, and then it kind of, I'm just going to move my equal sign here to this side, and then I have r cubed here, and then I'm just going to multiply basically. Let's just do tops. So I'm going to have plus 320 pi r squared over 2r, and then minus 3 pi r to the power of 4 over 2r. And I can just kind of neaten this up. So 2 over 3 pi r cubed, and this is going to be that's going to be 160. The pi is going to still be there, and there will be 1r at the top, and this will be minus 3 over 2, and that will be r cubed. Pi r cubed. There we go. Pi r cubed, and now I have like terms. So 2/3 minus 3/2 is going to be minus 5 over 6. Just getting the denominators the same, and then subtracting, and then this is pi r cubed, and then plus 160 pi r. And if I look at this, this is actually where I should have gotten. So 160 pi r, that's that part, minus 506 pi r cubed. There we go. So now I have a function of volume, and there's only one input, which is just the r. So now I can actually derive this. I'm going to derive it on this side just because I want to be funny. Let's say dv over with respect to r. So it's, not vd, dv to respect to r. And I'm going to derive, so the 3 times the 6, that's going to give me a 2. So I'm going to be left with negative 5 over 2 pi r squared. And that's just going to be plus 160 pi. And this is all equal to 0 because I want to find the maximum value. And that's going to be a stationary point. So that being all equal to 0, I'm going to divide the pi's away. And I'm going to multiply by 2 on both sides, well, everywhere, so that I can get the fraction away. So minus 5 r squared plus 320, I believe, is going to be 0. And then I'm going to divide by 5. So I'm going to have, let's just take this over to the other side. R squared is going to be 320 divided by 5. 320 divided by 5 is 64. So 64, and that is going to give me r is going to be plus or minus, obviously the square root of 64 is 8. Basically did this. But the radius has to be a positive value, so I'm going to ignore the negative value because I haven't seen rulers measuring negative values yet, but maybe they're out there, maybe in the iStore for imaginary numbers, I guess. But anyway, let's go. What did they ask us? Find the exact value of r. Okay, so we found that, so r is going to be 8. And they're also asking, oh, I think that's all they're asking. Find the exact value of r such as v is maximum. Okay, that was it. Usually they'll ask the actual volume, and if they did ask that, then we would just sub the r8 into here. But since they didn't ask it, we're not going to do it, but that's just calculator work. You'll get some kind of an answer there. But yeah, that's it.